All right, we're going to start off with set theory and logic. 3.1 is the types of set and set notation. In mathematics, the idea of a set is critically important. Many of our arguments in math are based around sets, particularly probability. So what is a set? Well, a set, allow me to just draw. So these are called, now that right one's kind of ugly, I'll try to do it again, forehead, nose, and chin. These are called set brackets. So anytime that you've seen these in math, it's automatically implied a set. What is a set? A set is a collection of items. That's all it is. So a set is a collection of items. What is an element? I'll get away from that sparkly color, or maybe I'll go black. An element is an item in that set. So, for example, I'm thinking, I'll say this slowly, I am thinking of all the numbers, all the positive integers from 1 to 3. So that would mean that my set would be 1, 2, 3. This is a set. An element is any one of those items in that set. What is the universal set? Well, the universal set, or sometimes I call it the universe, is a large set that provides context to another set. Now, this is a really abstract idea, but if I'm just taking a look at my previous set here, what might make sense is this is my set, and it's a specific set, and I can call this set A. But perhaps the universe to my set A just might be all positive integers, right? It's going to be a larger set from which we can build another set. What is a subset? Now, really funny, you've probably heard these words all the time in the English language. A subset is a smaller set made from a larger set. So if I'm sticking with my set of 1, 2, 3, perhaps a subset of that might be 1 and 3. Depends on how I want to define it. So maybe I'm looking for all odd integers from my set A, so I can say a subset of A is 1 and 3. An empty set. I'm just going to draw my empty set here. There's two ways to say an empty set. There. Here is my set. It contains nothing. Another way of saying an empty set is this. And really, the word that goes along with this is null. It means nothing. What an empty set is a set that contains no items. So just to give you a quick example of this is I'm going to give you all the perfect, not the perfect squares of set A. Maybe I'm going to say these are the first names of all the crocodiles that live in my classroom. So if that's the set, that's the collection of all crocodiles that live in my classroom, and really there are no crocodiles in my classroom, so that is an empty set. Now I'm going to stick with the idea of a complement. So if here is A, and I'm going to say A had the subset B. Well, I can say the complement of B is another set. Sorry, I'm just going to put complement is another set that contains, yikes, my handwriting got terrible there, that contains all elements not B. So for instance, let me just erase this here. The complement. Now I'm going to say the complement of B. So do you see what happened there? I just put a little prime beside the B. The complement of B is another set that contains all elements that are not B. So for instance, the very easy complement might be, let A be the complement of all even numbers. Then A prime is all numbers that are not even. Or A prime are the odd numbers. All right. Good times. We're almost done with the definitions here. So here, the disjoint set. Now, what you'll see here in this picture here. My picture. No, I shouldn't have highlighted this. This is called a Venn diagram. Venn diagrams are incredibly important when understanding sets. They help us visualize what's going on. So what is a disjoint sets? So disjoint sets are two or more sets that do not share common elements. Sorry, that should say elements. So if we take a look here at my Venn diagram, so if we make a Venn diagram here, what we notice is that set A contains the numbers. Set A contains the numbers 1, 2, 3, 4. Set B contains other numbers 5, 7, and 9. And there is no common element or common item between set A and set B. Therefore, they are disjoint. So now I'm going to try to get on with sets. Now, this is where the math class really begins. The phrase from 1 to 5 means from 1 to 5. So I'm just going to call this set Y. So Y is a set such that, now, did you notice I put those curly brackets? As a math person, as soon as I see those curly brackets, I'm like, oh, here comes a collection or a set. What goes in there? All the numbers from 1, 2, 3, 4, and 5. Presumably, when I said from 1 to 5, I meant integers. Another way of writing this, and you've probably seen this in other courses, is what I'm trying to say is I want all numbers, so 1 is less than or equal to x, is less than or equal to 5, comma, now x is a number. That's from 1 to 5. And I have to say x is an element of an integer. So let's pick apart this set notation. This is the rule to get in that set. And what that says is x has to be between 1 and 5 and includes 1 and 5. Well, is x 2.7? No, because x is an integer number. Sets are incredibly precise. They're a really great way to articulate your argument. So I'm going to go with the second notation. In set notation, the number of elements of the set Y written as ny. So as soon as we see an n in front of a set, so ny, here is how many elements are in Y. 1, 2, 3, 4, and 5. So this is the number of elements in set Y. Sometimes you may hear the word cardinality. But it's the number of elements in set Y.